Okay, using trigonometry to solve problems. So basically, when we're talking about solving problems in trig, we are just referring to the fact that we are trying to, solve a worded situation that involves a right angle triangle. Okay, and the only information we can get from it is either one side or one angle, or two sides and are trying to find an angle. Okay, so to do so, we're just going to follow this list of steps. So first off, you're going to draw a diagram and label the key information. Okay, so if you don't have a diagram, you need to draw one. If you do have a diagram, perfect, then just label it, if it's not already labeled. Okay, so then second, we're going to identify and draw the appropriate right angle triangle separately. So let's say you have like a tree and a person's looking up at a tree. Okay, so here's a little girl looking up at a tree. Okay, and we're told how far away from the tree she is. We can sort of work out where this triangle is going to sit in relation to where this girl is standing. Okay, so what you're going to do, so once you've got that picture, is you then just draw the triangle without all of the tree and the person, and all that sort of stuff. Anyway, we're going to then solve using trigonometry to find the missing measurements. Okay, so just using the stuff that we've done in the last few lessons. So that's SOHCAHTOA, for those of you following along at home. And then express your answer in words. So basically, you're just going to actually answer the question. What have we learnt from this? The tree is this high. We're actually asking you a question in these things. You need to answer them. So two things I want to talk about are the angle of elevation and depression. So believe it or not, these things here are eyes. Now, these eyes are looking in certain ways. Say you're looking along the horizon. So say you're at the bottom of a cliff and you're looking at the base of the cliff. And then your friend shouts out to you who's standing on the top of a cliff. Well, what do you do with your eyes? Your eyes are going to go up. And that angle that your eye, so looking down at the base, goes up to see your friend on the top of the cliff, that is your angle of elevation, because your eyes are actually elevating a specific angle to see your friend up there. Alternatively, let's say you're standing on top of a cliff and you see a little boat out on the harbour. Okay, so you're on the top of the cliff and you're looking out to sea, and then you hear some noises coming down below. You look down and you see a little boat on the harbour. Okay, so if your eye looks down, whatever angle or how far your eye looks down is whatever angle that is. It's called the angle of depression. So my cute little boat's going to go now. Okay, so it's basically how far down are you looking, or how far up are you looking, and what angle of up or down are you looking. Okay, and there's one other thing I want to touch on. So the angle of depression and the angle of elevation are very, very closely related. Okay, so the angle of elevation so you can actually calculate the angle of depression from the angle of elevation. So you can use the angle of depression or you can use the angle of elevation to work out what the angle of depression is. And in a lot of cases, that's going to give us a triangle. It's going to help us a lot more. Okay, so have a look at this diagram. So we've got AB is parallel to CD. So that is, if I was to draw a line like this, okay, call it AB, and I have a line across here called CD. So it goes from through 2 points AB and then through 2 others CD. Now they're parallel, so that means that they won't meet, and it means if I draw a line between the two straight, if it meets at 90 degrees there, then that angle in there is also 90 degrees, okay? So these two lines, if, for example, let's say, here's you standing on the top of a mountain, and here's your friend down here, sitting at the bottom, okay? And, your friend shouts up to you, so you're looking, over a valley or something, it's a very pretty sight, and your friend shouts out to you. So what do you do? So you look down to your friend and you look at a certain distance. Well, what this is saying is, if you're looking down to your friend like that, your friend actually has to move their head up, so in the opposite direction, but the same amount. So, if you look down 20 degrees to see your friend, okay, your friend only has to look up 20 degrees to see you. And it's a really cool fact, because it means that if we have a triangle on this side here, like this, then that gets translated across by essentially flipping it. Now, some of you might see that, two parallel lines, and we've got a line bisecting them at 2 different points, like this. You'll notice from our geometry topics back in year 7 and 8, that if I have 2 parallel lines being cut by a third line that's not parallel, because if If it's parallel, it won't be cutting them. Then, come back. Then, we make this Z-shape thing. And remember, if we have a Z-shaped thing, then this part here and this part here are equal because of alternate angles. Okay, so those alternate angles are what makes this fact true. The fact that, your friend has to look up the same amount of degrees that you have to look down at him or her. Okay, so let's move on to some examples. Now, for this example, what we're going to do is we are going to basically just find some angles. So what we're asked to do is we're told that we've got an angle in here of 32 degrees. Okay, and we need to find the angle of elevation of A from B. So that's A from B. So that part's really important. If you're coming home from school, you're starting at school and you're going home. So you're going home from school. You're going to A from B. So we're starting here. So the angle of elevation means we're going up. So that's that one in there. And, well, how many degrees is that? Okay, so we've got 32 degrees in here. And we know that if these two lines are parallel, and this line, or this line and this line make a 90 degrees, then this one and this one also have to add up to 90 degrees as well. Okay, now that fact's going to help us because if this part here is 30 degrees, and I know that this part has to add up with 32 to be equal to 90. So what plus 32 degrees is equal to 90 degrees? Or in other words, 90 degrees minus 32 degrees is equal to, not 52, 58 degrees. So this in here is equal to 58 degrees because 58 plus 32 adds up to 90. Okay. So therefore, that is equal to 58 degrees. Okay. Now, we're going to use that fact from the other side, and I'm going to show you another way to do this one as well. Now, the angle of depression of B from A, so we're doing this direction here. So we're trying to work out, well, what's this one in here? Okay. Now we can use that fact on the previous page so that, the one on the inside is the same as the one on the outside and above. Okay, so using just that one fact, we can say, well, we know this is already 58 degrees. Like, it's that easy. So it's 58 degrees as well. Okay, because your friend has to look the same amount of degrees as you. Now, the other way that we could do this one is we could say, well, we know that this is a triangle. Okay, this is a triangle. What do we know about triangles? What do triangles' angles add up to? And hopefully you answer with, well, they're up to 90 degrees. Not 90, 180. 180 degrees in a triangle. But we already know two of the angles. We know that one of the angles is equal to 90, and one of the angles is equal to, not 58, 32. Okay? So our missing angle must be equal to 180 minus 90, which is just 90, minus 32, which is also equal to 58. Okay, so that's two ways that you can answer that one. So both of those ones are equal to 58. Okay, so this is just an alternative method to work that one out because it's a triangle, or we can just use the fact of alternate angles to work out that 58 and 58, like they must be the same. Now, I've got 3 more examples for you guys. The next 2 are going to be questions based on 3 to 10, and then the last one will be on question 11. So these ones are all worded questions. So there's actually, there's not a lot in these questions. Okay, it's just describing a situation. So the angle of elevation of the top of a tower from a point on level ground 30 meters away from the base of a tower is 28 degrees. And all of that is mentioned in here. So the angle of elevation is 28 degrees. He's at 28 degrees here from the bottom to the top. 30 meters away. So, the distance from the base is 30 meters. And that's that 30 meters in there. Find the height, h, of the tower. Okay. So what we're going to do is we're going to find, well, what's this height equal to? So the first thing that I said to do was draw a picture. Now, we don't need to draw a picture in this one because we've already got our picture there. And we've also actually got all the information added in too. So what we're going to do next is we're actually going to draw our own triangle. So we're going to start off by drawing our own triangle just like that. See how this one just has none of the other information on it? Okay, all I want to add for this one is I want to add the 28 degrees. I want to add the h, and I want to add the 30. That's all I want. I don't want the line of sight. I don't care what the tower looks like. Okay, I already know what the angle of elevation is. Okay, I can, just draw an arrow to indicate that. So what we're going to do now is we're actually going to use some trig to work this out. So what you should have done, because it's a trig question, is at the top of your page. We're going to start off by writing, whoa, that's not an A, SOHCAHTOA. Okay, so SOHCAHTOA. So with SOHCAHTOA, we can then answer this question about this right angle triangle. So let's look at the triangle over here. So we've got 28 degrees, H and 30. Okay, so just drawing it out. So let's use a different color for this so we don't doesn't become such an eyesore. Okay, let's use black. So let's start by labeling our triangle. So, we've got the hypotenuse over here. Okay, so there's nothing that's with the hypotenuse. So, I don't want the hypotenuse in this one because there's nothing there. I don't know any information about the hypotenuse, nor do I need to. So we'll ignore that one. Then we've got our H over here corresponds to our opposite. And my 30 over here, it corresponds to my adjacent. So opposite and adjacent means I'm using TOA or tan. So tan theta is equal to the opposite. So the opposite side, opposite over the adjacent side. Okay, so the opposite over the adjacent. Okay, so that is, my angle, tan of my angle, which is 28 degrees, is equal to the opposite, which is H, over the adjacent, which is 30, like this. Okay, now to remove the 30 from the right hand side, because we want the H by itself, we are going to multiply both the left hand and the right hand side by 30. So we get that H is equal to 30 times tan 28 degrees. Okay, and so I'm going to let you guys finish that one off, okay, because it's just a matter of putting it in your calculator, which we've already done. Okay, so that one's done. Okay, next question. From the top of a vertical cliff, Andrea spots a boat out at sea. If the top of the cliff is 42 meters above sea level and the boat is 90 meters away from the base of the cliff, find Andrea's angle of depression to the boat to the nearest degree. Okay, so let's draw a picture because that's what we've been told to do for step one. So look at this. This is a pretty cool cliff if you ask me. Okay, got some sea happening because she's out at sea. Andrea's up on the... I'm going to put some pants on her. Okay, and a t-shirt. There's Andrea out at sea. Or not out at sea. She can have a hat as well. Okay, she is sitting up there and she spies a boat. So, let's start off by writing how tall is this cliff. Okay, this cliff is going to be, from sea level, is 42 meters. Okay, so 90 meters away from the cliff. Okay, so 90 meters away. So that's about, this far. So 90, I'm going to indicate that, 90 meters. Okay, there is a boat. So it's a little boat. Chugga chugga. Big ocean. Must be a stormy day. No, we'll make it sunny day. Look at that. Sunny day. Now, that little boat out at sea is 90 meters away from shore. So what we need to do is, basically, how far down does Andrea need to look so that her line of sight matches the boat? Okay. Like that. Okay, so basically I'm asking, what's her angle of depression? What's that angle up there that she's looking down at the boat? Okay. So, you'll notice something about this question, this problem, and the main problem is that, we don't actually have a triangle to work with. The angle that we're trying to find over here is actually outside of the triangle that we've got set up with the height and the base of our other triangle, okay? So, one of the things that we could do is that we could actually transpose this height here and this length here across here and up here and move the triangle that way. That's one thing you are allowed to do, okay? So instead of having a triangle look like this, your triangle will in fact look like, so if I can, I'll draw it properly because it might be the one that we use. So this triangle like here, here's my theta in here. 42 So the height, like the line of sight from where she sits is still the same. Like this height here is still the same. It doesn't matter where you look. The height from where she's looking down to the sea is always the same, okay? So we can actually move that 42 meters to over here. And alternatively, with the 90 meters, okay, it doesn't matter whereabouts it is, or except for, the fact that our cliff has a massive gap in it, but the boat is always going to be 90 meters away, okay? So we can put the 90 up there too. The other way to do this one, is to remember that if this angle of depression, so her looking down at the boat, is the same as if the boat was having to look up at her, okay? And so the other triangle that you could draw would look like, so theta in here, 42 over here, and 90 here. So this is what our triangle would look like, okay? You can use either one of these, and they both will give you the correct answer, okay? So with that being said, let's rub out this bottom one, and we'll just use the top one for this example. Okay, so Sokotoa is on the top of my page. Sokotoa right there. Let's work out, well, what are we going to be using? We have an opposite, we have an adjacent, we have no hypotenuse, so opposite and adjacent. Again, we're going to be using tan. So tan theta is equal to the opposite over the adjacent. So we're going to be using this one. So we don't actually know what theta is in this one though, so we're going to leave it as tan theta, and that's going to be equal to the opposite, which is 42, over the adjacent, which is 90, okay? So if tan theta is equal to that, remember theta is equal to, we need to use the inverse, because we're trying to find an angle for this one, we need to use the inverse, okay? And then I'll let you guys finish that one off. And then don't forget to write a sentence. So the angle of depression is equal to whatever you get, okay? So I'll leave that one for you guys to do again, because it's just a matter of putting it into your calculator. I'm just showing you the method on how to do it, okay? Again, just putting it in the calculator is just putting it into your calculator. All right, last question. A plane flying at an altitude of 1,500 meters starts a climb at an angle of 15 degrees to the horizontal when the pilot sees a mountain peak 2120 meters high, 2,400 meters away from the horizontal. Will the pilot clear the mountain? Now, this is a cool question because it actually has having you think outside the box a bit. It's not actually just asking you what a number is. It's actually asking you, well, with all this information, is he actually going to pass this mountain, or is he going to hit it? So we're going to start off by drawing a picture, as we always do. So a plane is flying at a height or an altitude of 1,500 meters. Okay, so here's my plane. Cockpit and tail, like a fish. All right, maybe we put a jet engine on the end. Okay, so basically this plane is going to start, so it's traveling this way, okay? It's going to start traveling up at a rate of 15 degrees, okay? Angle of elevation of 15 degrees. Okay, so what we're saying is the pilot sees a mountain peak of 2120 meters. So here's, oh, that's not a mountain. Here's a mountain, okay? So the question is he going to clear it, or is the 15 degrees not enough that he's going to smack straight into it? Okay, so how are we going to answer this? Well, we know that the plane is 2,400 meters away from him, horizontally. So that's that distance there. We also know that the plane is 2,120 meters tall. But what we want to know is, after he travels the 15 degrees, what's the actual height that he's going to be at by the time he gets to that mountain? What's the actual height in here going to be? So I don't actually care about the fact that this is equal to 2,120 for now. all I care about is what is this height over here equal to. So if I extract this information into the triangle over here, I've got my x, which is my unknown height, or h for unknown height. We'll use x in this case, I think. We've got 2,400 meters for how far the plane is away, and we've got an angle of elevation of 15 degrees, okay? So, basically, if this number here is bigger than 2,120, he's going to pass it. If it's smaller, he's going to hit it. So, let's work it out. We've got an opposite. We've got an adjacent. We're going to be using, because I wrote this at the start and not halfway through the question, we're going to be using TOA again, or tan. So tan theta is equal to, actually I'll just put the number straight in. Tan of 15 degrees is equal to opposite, which is x, over adjacent, which is 2,400. Okay, times both sides by 2,400. So times and times, and we get, 2,400 times tan of 15 degrees is equal to x, or x is equal to, I'll actually do this one for you, so 2,400 times tan of 15 degrees, and that gives us 643 meters, okay, to the nearest meter. So automatically you might be thinking, well, that means he's going to hit it, doesn't it? Well, not quite. Remember, he already started 1,500 meters in the air. And the top of this mountain, so from the ground, this mountain was 2,120. So how much extra does this 643 make the pilot in height before he passes that mountain? Okay, so all we have to do is, so 1,500 plus 643. Okay, so adding these two together, we get 2,143. Is that bigger than 2,120? Yes, it is. So he will pass the mountain by, and he's going to pass it by not much, only 23 meters. So he's pretty much just going to scrape over it. So think about that, 2.5 kilometers away, and he's only just getting over it. So 15 degrees. If it was 16 degrees, he'd be much, much over it. I can assure you of that. Anyway, with that being said, that's the last question. Question 11 onwards is considered extension as per normal. Okay, it's not compulsory, but I say recommended, but if you want to give it a go, have a go. It will, improve your marks in some way, I'd imagine, particularly if you're getting them all right. So have a go if you want. If not, that's okay. And I'll see you guys for the last video on bearings.